Hello, ma'am.
Yeah, good afternoon, madam.
A very delightful evening to you all present here. Reputed guest speakers, great orators, distinguished personalities, esteemed participants. I, Dr. G. Jyoti Olivia, Department of English, wholeheartedly welcome you all for this one-week international webinar from Faculty Development Program on recent advances, future trends in artificial intelligence and cybersecurity. It gives me immense pleasure to introduce our today's guest speaker, Dr. Tejaswini Potluri, an assistant professor of Department of Computer Science and Engineering, VNR Vignan Jyoti Institute of Engineering and Technology, Telangana. Before we commence the session, Let us implore and seek in God's divine and bountiful blessings by Sister Sureka, First BSc.
I come before you today. I come before you today, and there's just one thing that I want to say. Thank you, Lord. Thank you, Lord, for all that you've given to me, for all the blessings that I cannot see. Thank you, Lord. Thank you, Lord. With a grateful heart, with a song of praise, with an honest song, I bless your name. Thank you, Lord. I just wanna thank you, Lord. Thank you, Lord. I just wanna thank you, Lord. Thank you, Lord. Thank you, Lord.
Thank you, sister, for your melodious song. Dear participants, I would like to give you a few instructions to you all. In order to avoid inconvenience among the participants, kindly mute your audio and switch off your video throughout the webinar. If you have any questions regarding the topic, please post your questions in the chat box and the queries will be clarified at the end of the presentation. Thank you for your kind cooperation. I cordially welcome Dr. Sister Teresa Marade, the correspondent of our college, Dr. Sister Shiny KP, the principal, today's distinguished speaker, Dr. Tejaswi Potluri, an assistant professor of the Department of Computer Science and Engineering, and all the esteemed participants, honorable guests, renowned family members, and academicians, and across the country to this international webinar from Faculty Development Program organized by the Department of Computer Science, JMJ College for Women, Tenali. It's a great joy for me to introduce our excellent speaker, Dr. Tejaswi Potluri, an assistant professor of the Department of Computer Science and Engineering. She has obtained PhD degree in the year 2023 with the specialization of Computer Science and Engineering, and she had been teaching experience for the past 7 years. Her special interest focused on her teaching and learning on software engineering, data structures, unified modeling languages, computer network, and her novel techniques in teaching and learning adopted in coding, wit and will plickers, think, pay, share. To her credit, around 5 programs were conducted, which are 1 week certificate program, national level workshop, national level FDP, and online certification on Flutters, and a designation to students from 14th and 15th May 2022. To acquire more knowledge as a prudent researcher and a zealous academician, she was attended around 4 FDPs, 5 NAT workshops, and certificate courses, etc. She had delivered 5 eminent lectures on her respective subjects. She has published her papers in peer-reviewed journals in International Scopus and SCI. She has presented her research papers in national and international journals. She has completed her project work on whiteboard animation videos with a worth of 1 lakh during her stipulated time. She was recognized as a faculty champion in the program University Innovation Fellows from Stanford University. Besides this, she is one of the top performers in the AICTE approved 4-week FDP by IIT Bombay on use of ICT in education for online and blended learning. Now, I cordially invite our resource person, Dr. Tejasvi ma'am, to take over the session on facial recognition using deep learning. Welcome, ma'am.
Thank you, ma'am. Thank you so much.
Thank you.
Just give me a minute. I will share my screen. So just wanted to check if screen is visible. A very good evening to all, and I would like to thank JMJ College Management and all the coordinators for giving me this opportunity to share my knowledge to all the participants here, and a very lengthy introduction given by sister. Thank you so much. So let's start this session. So today's topic is face recognition using deep learning. I think nowadays these are being a very fancy terms like artificial intelligence, machine learning, deep learning, and a lot many applications by using these technologies. So let's be specific to an application. And before starting with the specific application, let's see very few basics of what do we mean by artificial intelligence, machine learning, and deep learning, and what is the difference between these three. Because being a researchers, if you want to start with the research and so we have some problem statement, and if you want to select some algorithms, now there will be a big question to us, like whether we need to go with machine learning or deep learning or anything else. So to get answer for that question, so we need to know what is a small difference between these three different terms. Okay, so this is today's agenda. Let's see what do we mean by artificial intelligence, machine learning, and what are the different applications. And later we shall see what do we mean by deep learning. And next we shall see one of the application face recognition and a model which has been already implemented for face recognition. So let's start with artificial intelligence. So this is a very broad term, and let's see, like artificial intelligence is not a domain. Okay, so we are having different problem statements, and we can have different domains where we can use artificial intelligence to get solution for that different problem statements. Okay, so here coming to a simple definitions, like you can see, like artificial intelligence is an extensive branch of computer science that focus on building smart machines. These smart machines, what we are using in our day-to-day life. So there is no need to do, there no need to think much like what are the applications of artificial intelligence, where we have to use this, where we have to implement this. The very, very tiny things that we are using in our day-to-day life is embedded with AI. See now, the session, even here we are having an AI application. The mobiles we are having in our hand is having AI applications, and the banking apps we are using for simple phone pay, GPay, those have simple AI applications. The WhatsApp, the Insta, Twitter, these are having AI embedded into it. So let's see a few applications also in the later slides. So, who has coined this artificial intelligence term? It was coined by an American computer scientist John McCarthy in the year 1956. So now, these AI have many subsets like big data, machine learning, NLP, which is nothing but natural language processing, deep learning, and so many. So the few applications or examples here we can find like face ID. Simple, the face ID is nothing but, suppose whenever we are having we are using the smartphones, just we can unlock our smartphones just keeping phone before our face, it is going to match our face, which is a simple application of AI. And also the simple search algorithms we are implementing it can be in like Google, or it can be in a simple mobile where we are being searching for a WhatsApp contact or one of the contacts in our contacts page. And also the recommendation algorithms like which these are implemented in the online shoppings. Okay, we are getting some recommendations, or it can be a simple YouTube. So whenever we are playing a simple video in YouTube, so in the beside you can see a recommendation list, which is done by using an AI algorithm. Okay, so let's see few more applications for AI. Like the first one, you can see like email filters, which we are using in our day to day, which are we are AI algorithms allow for advanced filtering of these emails. This, you can see, observe the spam folder. Okay, the spam filtering system, what does it do means it continuously improves by learning from vast data sets. These filters can use sentiment analysis and also NLP, which is nothing but natural language processing, to understand emails better and segregate them from the more important ones. So, this is a very simple example of AI in email filters. And next example, we can see it as a simple search operation in online shopping. So there are many examples of AI in e-commerce, including personalized product recommendations, chatbots, virtual shopping assistants, dynamic pricing, fraud detection, and also logistics optimization. AI can also help to analyze customer reviews and also to improve product design and marketing strategies, which you can observe in any online shopping like Amazon, Flipkart, Mintra, whatever it is. So let's see one more example like smart homes. In smart homes, AI not only allow voice commands to control many devices, but also it provides useful information such as cooking recipes or weather forecast directly from your fridge or oven. Enhanced energy efficiency of AI is used to optimize the energy usage in appliances, resulting in significant electricity and cost savings. So now let's see about the what do we mean by machine learning. Okay, so next you can better understand what do we mean by artificial intelligence and what is machine learning and what is difference between these two terms. So this machine learning actually it is a specialized technology that falls under the umbrella of artificial intelligence itself. This exciting field is the driving power behind many modern technologies like image recognition, self-driving cars, and products like Amazon, Alexa, Siri, and so on. So machine learning is not completely different from AI. It is subset of AI. So you should be very clear. So if someone comes and says like I'm using AI, it doesn't mean that he is not using machine learning. Okay, the machine learning is a subset of your AI. So machine learning involves showing a large volumes of data to a machine so that it can learn and then it can make predictions, and also it can find some patterns or it can classify data. Okay, so now here even you can observe in this slide like You are giving a large volumes of data. It is going to learn, your machine learning model is going to learn from this large amount of data, and then it is going to either predict, or it is going to find some patterns, or it is going to classify data. Okay, so we have different types under this machine learning. We are having three different categories under machine learning. One is your supervised, and next it is unsupervised, and the third one it is reinforcement learning. So let's see in brief about these three types of learnings. The first one, it is your supervised learning. So here in this machine, actually this is named as supervised because the machine itself, it is unsupervised machine. Because while it is learning from the data given by the user, it is under supervision. Okay, it's learning meaning you are feeding the algorithm information to help it to learn the outcome. So now here you can see, for example, the input I'm giving to my supervised learning model, it is I'm going to give some pictures of apples here, and I am also giving the label to these apples, like these are apples. So I'm giving the image along with the labels or annotations. So now my model will learn like, okay, if the image looks like this, the name of this image is apple. Okay, so now how can I test it? So after now the model have learned something from the data I have given to it. So now I will give some image of apple, and now it is going to tell, okay, it is an apple. It is going to predict it. Okay, so just it is going to use the data which is learned under a supervision. Like I am giving it, this is image and this is the name of it. Like what do we do for our kids at our home? This is supervised learning. Coming to some technical details, like if you want to know some algorithms which can be used in the supervised learning, or like it can be neural networks, decision trees, linear regression, and support vector machine. And some real-time applications of the supervised learning can be like predicting real estate prices, classifying whether these banks are bank transactions or fraud, or their correct transactions. Okay, so next moving to the unsupervised learning. So here you can see like it doesn't use the same label training data or training sets. Instead, this machine looks for less obvious patterns in the data. Okay, so this is very helpful when you need to identify patterns and then use this data to make decisions. Okay, so now here you can see just it is not going to give any annotations here. I'm not giving like this is apple, this is watermelon. I'm not going to give any labels here. Just I'm going to classify these into different patterns. It is going to observe, okay, these are all these belongs to one pattern, and these watermelons belong to another pattern. Okay, so coming to technical details, you can see like the most common algorithms used in unsupervised learning are, it can be like k-means, hidden markup, hierarchical clustering, and Gaussian mixture algorithms. Okay, so coming to the third one, it is reinforcement learning. So this algorithm or agent used here learns by interacting with its environment, and then it gets a reward. It can be, the reward can be a positive or it can be some negative reward. If it coming to some example here, you can see like see this, suppose this dog is barking. Okay, this is the action given by this dog, and now in response to it, this agent, which is nothing but dog here, is going to receive and reward in response. Here it is going to receive a negative reward, like the girl is going to hit because it is barking over that girl. Okay, so as it has been receiving a negative reward, it is going to observe, okay, this is, so when I bark, I'm going to get some negative record. So by observing it, it is going to learn itself. Okay, so coming to technical details, so the common algorithms which can be used under this reinforcement learning, or it can be like temporal difference, Q-learning, and deep adversarial networks. I think the most research is going happening here. And some real-time examples of this reinforcement learning can be the teaching, cars to park themselves, or you can say like autonomous driving, self-driving cars, Tesla cars, and this dynamically controlling the traffic lights to reduce the traffic jams. Based on the jams, the timing for each signal will be varying. So these are the applications where reinforcement learning is being used. Okay, so now so by by combining all this, the applications of machine learning can be in many areas, like in the manufacturing industries and healthcare and insurance. It can be in customer service, transportation, e-commerce, automobile, anywhere the machine learning can be applied. The one thing to continue your research is just to come up with some problem in your day-to-day life. Then you can get a solution by using machine learning. So then you have to think, okay, how can I give solution to this problem? Okay, it doesn't mean like, okay, only in these specific areas we can apply machine learning, not to the remaining sectors or the remaining applications. Okay, so now let's see what is deep learning. Okay, the next fancy term, it is the deep learning. So actually, these deep learning algorithms are modeled to work like a human brain. These learn from large amounts of data, and these are being trained with the large amount of data. That's the main difference you have to observe between deep learning and machine learning. Like, you need very large amount of data even to perform the training. That because the training happens only with a large amount of data for deep learning models, then only it can perform well. If you're going to take a deep learning model and if you're going to train them with a very small amount of data, you're not going to get a more accurate or the most relevant outputs from it. Okay, so this training with a large amount of data is what configures the neurons in the neural network. So you're having different layers here. You can observe like input, hidden layers, and output layers. It doesn't like you're having only two hidden layers. Just have given a simple figure just to understand what is a deep learning here. So these deep learning models, once trained, then it will be able to process new data. And so this deep learning models take in information from multiple data sources, and also it can analyze the data in real-time applications. So to implement your deep learning models, you require a GPU, graphical processing units, which are optimized for training your models, your deep learning models, because these GPUs can process multiple computations simultaneously. Simply, this deep learning is a name for neural network with many layers, like input, hidden, output. You can have many under hidden layers. Whereas coming to your machine learning models and all that, you're having input and output. But coming to deep learning, it is a simple neural network which is a bunch of different layers. So when information passes through a layer, each node in that layer performs a very, very simple operations on the data and selectively passes this results to other nodes. Each subsequent layer focuses on a higher level feature than the last layer until the network creates the output. So the same process is being repeated until the output is processed and output is given to the final user. So this is what your deep learning. Again, in short, your deep learning is also a subset of artificial intelligence. So now here you can have a simple picture of all these three sets. Like see the big set you can see observe here. It is artificial intelligence. It's a type of advanced technology that mimics the human intelligence. Okay, so in that you are going to have a subset like machine learning. See here you can see it is a subset of AI that learns patterns, okay, from analyzing large amount of data, in which you are having different types of machine learning. Okay, supervised, unsupervised, reinforcement. And again, coming to your deep learning, again it's a subset of ML where you are having a neural networks with with a bunch of layers. Okay, and also these what does these deep learning differs from machine learning? It learns with a huge amount of data. Okay, so now your deep learning is a subset of machine learning. Again, your machine learning is a subset of artificial intelligence. Okay, so now let's see a few applications of your deep learning. Like it can be, it's a very specific, like cancer tumor detection, coming to your medical applications, and caption bot for captioning an image, music generation, image coloring, object detection. I think we can see our students doing projects in these areas nowadays. And you're having different types of neural networks like convolution neural networks, recurrent neural networks, generative adversarial networks, and deep belief networks. So based upon the applications, you can select these different types of networks. So now coming to our specific application of one of the application of your deep learning, face recognition. Today we are going to discuss about the face recognition. So before starting with the face recognition, let's see, we are listing two types of terms like face detection and also face recognition. So let's see the difference between these two terms. So now here you can see, suppose when I'm going on the road, I have we will be seeing a lot many people traveling along with us, right? We know that they are humans, they are persons. We are detecting them. Just we know they are person. They are some people. That is just you are detecting. But now among that people, suppose if you are able to recognize like, hey, this is Ram, is my friend. It means that you are able to recognize him. That is face recognition. But with what happens with the remaining people? Just you are going to detect like, okay, here's some person, here's some people, but I don't know him. You are not able to recognize him. Just you are going to detect, okay, here it is not a robot, he is some human, or it is not a some animal, he is some human. Okay, so now here you can see, coming to this picture, you can see like this is a group picture where you can, or if it is coming to your deep learning model or machine learning model, if your model is going to detect, okay, this part, see now around the face you have seen some boundaries here, circles drawn around the faces. So in the first picture, it is like your face has been detected. That is, your model has drawn just a circle around your face. It is able to only detect that this part is a face, but it doesn't know who it is. Okay. But coming to the second picture, here it is able to say like, okay, the first one is some A, the second face is belongs to B, the third one is C, and the next belongs to D, and so on. This is an example of recognition. So this is the main difference between detection and recognition. So before going with your recognition, so your model should the first step should be able to detect faces in your image or in the frame of a video. What is video? So always your videos will be processed in the terms of frames. Again, which in turn the frame is nothing but an image. So first your model should able to detect where the face is located in the image, and next it should be able to recognize who it is, whether it is Ram, whether it is Sita, or someone else. Okay, so let's see what are the different steps to be included under face recognition. So as we have discussed till now, the first basic step to start with face recognition, it is face detection. So in your image, your model, first it should be able to detect where the face is located, as we have seen before. So after detecting the face, see for example, the student or some person X is turning backwards. Okay, okay, my model is very accurate. It has even drawn a circle around the head of that face who has turned, who is showing his back, like some faces detected. But how could I recognize without seeing his face, right? Even being a human, we can't do that if the person is turning backwards. Okay, so to overcome that, the next step it is face alignment. After detecting the faces in your image, your model should be able to detect the faces which are aligned towards the camera, which is nothing but you should be able to see his face. If the person is turning towards back, or is you see he is completely turned towards some right or left, if it is okay, if just it is he is turning about 45 degrees, or okay, even some 80 degrees is also fine, but he is completely turning towards left and right, just we are able to see only his ear part, it will be very difficult to recognize who it is, whether he is A, B, C, or X, some X. Okay, so to overcome that issues, your model should be able to even detect the faces which are aligned towards the camera. This is the next step. And following with the face alignment, the next step it is feature extraction. Okay, so now we are ready with the detected faces and also the face is aligned towards the camera. Now your model should able to extract the features of the face, which is very crucial step in the face recognition, because the accuracy, the performance of your model depends upon the algorithm or the model or the technique what you are using for the extracting features at this step. So you have to, your model should able to extract the features from the aligned faces. The features are nothing but like it can be, for example, again it should be able to detect where eyes are located, where nose is located, where mouth is located. Your model is going to give some key points. It's just going to draw some dots, like you can see in the kids books we can see like they will be giving some dots with some numbers, and we ask them to join along with the series. The kids go on joining the dots, you will be getting some image, the same process. After recognizing your faces, if you whenever you are extracting, so you are going to get some dots, which you can call, technically you can call it as a facial key points. Your model should able to extract facial key points of the detected aligned face, which can be used to recognize the face. Okay, so how many facial key points are being extracted is depends upon the model you have selected, which again in turn affects the performance of your model. And after extracting your features of the aligned face, the next step it is feature matching. Okay, now I have some person X. So I have extracted the features of the X face. Okay, and I'm having some database with me. Suppose if I'm trying to match the features of some my class students of my class, so I'm having some 70 students in my class. So I'm having a database where I have all the images of my class students, and now have given some X image as input to my model. So my model has extracted features of the X, and now it is going to match the extracted features with the features of all the 70 students which are stored in the database, which is nothing but feature matching. Because now, because I know my whatever the images I have in my database, we know some first person in database is some A, and the next it is B, next it is C, D, and so on. So now I keep on matching. So wherever the features matches, so I just keep on clustering them, and finally the face matches with only one person. So that now you can recognize who it is, whether it is A, B, C, D, or so on. Okay, so these are the main steps of your face recognition, like face detection. Next step is you have to check the aligned faces, and next you need to extract the features of aligned faces, and next we need to match the features extracted with the features of images in our database, and next we should be able to recognize the face. Okay, so we are having many deep learning methods for implementing face recognition, like VGG face, FaceNet, OpenFace, DeepFace, DeepID, DIL, BARFace, many. I have specified only very few. So among this, we shall discuss one model in today. So now we shall see the base of FaceNet. So coming to FaceNet, so now here you can see the first one, it is MTCNN methodology, just how the face recognition happens. So let's start with the network MTCNN, that multi-task cascaded neural network. MTCNN stands for multi-task cascaded neural networks. The structure or the architecture which you can see here, it is a simple example of MTCNN. So this MTCNN is a freely available. You can get it from the GitHub. So there are done a few modifications to this MTCNN. So it is named as an attentive net. Okay, you can search in Google. You can get some essay papers on this attentive net. Okay, which is used for face detection, and later you are having proctor net. In combination you can use it for face recognition. Okay, what happens in this attentive net is, so this attentive net you are having a cascaded neural networks. Okay, you can see you are having different layers. Okay, you are having cascaded networks here. So in this you are having three different cascaded networks: NPNet, NRNet, and ONet. So this NPNet stands for naive proposal network, and next naive refined network, which is nothing but NRNet, and next ONet, it is nothing but output network. Okay, so now here you can see you can have you can see like you're having different convolution networks, in between where you are having some naive inception module, and you are also implementing max pool functions, and you're also having a prelu activation functions here. And now here you can observe, like in NRNet and output net, you're having fully connected layers, which it is not available in your NPNet. Okay, so the output of each, so the input, the images will be given as input to the NPNet. So after processing in this entire NPNet, you're going to get two outputs here. You can see here, you're classifying faces, and next also you are giving bounding boxes. See, just bounding boxes is nothing but in our first figure you can observe, like we have drawn some circles around faces. Okay, so now here in this attentive net, they are drawing the bounding boxes in the shape of rectangle. So now we are going to classify your faces, and next you are going to draw bounding boxes around that faces. So these outputs what are extracted from NPNet will be passed to the NRNet. Okay, this I1 is given as an input to the NRNet. Now you can see this I1 is nothing but output of your NPNet. Again, this is given as a input to your NRNet. Okay, again the process, it is processed where see, now we can observe, like you can get a question like, okay, the output of NPNet is also a face classification along with bounding boxes. The output of NRNet is also again face classification along with bounding boxes. But the difference here it is the NRNet is going to refine the result given by the NPNet. Okay, actually what happens here it is, so now here you can see the basic steps what happens in these cascaded networks. Like the first you need to create a pyramid of images, because see, our model should able to detect all types of faces. See, suppose if I'm taking an image of a class, the student sitting in the first bench, his face may be visible very clearly or completely, and also, it may look like in a large size in an image when compared with the student who is sitting in the last bench. So the student sitting in the last bench, his face may be visible, partially visible, and also it may when comparing with the student who is sitting the first bench, it may be little small. Okay, so you are having faces with the different sizes, but still your model should be able to detect the faces with the different sizes. So to make ready, so our model should be ready to detect the images with the different sizes or faces with the different sizes. What we are doing is, as a part of training, what we will do is, okay, we are going to construct, we are taking an image of some x. Okay, so now this image of x will be converted into different sizes. By using this different images of different sizes, we are going to construct a pyramid. See, when you can see, like when a pyramid, it will be in a cone structure where the top will be just point, and slowly the size will be increasing towards the base. So this increase in size is nothing but the increase in the size of your images. So you are going to give this pyramid as input to your NPNet. So here what we are going to do is, first we are going to convert this by using 12 by 12 kernel coordinates. Okay, so where you are going to use the stride value as a 2. The stride value as 2 is nothing but after completing the operation, so you are going to just add plus 2 to your coordinate values. Like suppose, for example, if you are starting at 1, 1, the first pixel where you are processing it is 1, 1. If you are going with stride value 2, so next you have to process with 1 plus 2, it is 3, 3, 3. Okay, so in this AttentiveNet, we are going to implement the stride value 2, and you are going to convert all your 12 by 12 kernel coordinates to unscaled image coordinates. And after completion, after passing through all these convolution layers, so at the last you are going to implement non-maximum suppression for each scaled image. See, here you are getting some output here, right? Okay, at this last stage, for every layer, like after passing the image to through all the layers of your NPNet, you are going to implement non-maximum suppression here. And again, after passing your images through towards all your NRNet, after completion of this fully connected layers, again you are going to implement non-maximum suppression. The same happens at the end of your ONet also. What it is non-maximum suppression is, usually what we do is, suppose we are getting a multiple bounding boxes. Now here you can see like these bounding boxes are overlapped with each other. Like, okay, so now if in an image we are getting this overlap boundary boxes, what we do is, see, suppose if you are having multiple faces, like 4 or 5 faces, so for each face we are drawing boundary boxes, but these boxes are overlapped with each other. So what happens it is, if you are having overlapped boundary boxes, we are going to calculate the size of boundary box. The box with the lower size will be deleted, because it is very difficult to our model to recognize if you are having overlapped boundary boxes. Okay, so just to refine the results, we are going to remove the overlapped boundary boxes. So whenever you are deleting this overlap boundary boxes, what happens usually it is, the boundary boxes with less size will be removed. Okay, which is not which is not suggested in all type of applications, because even though the boundary box size is less, maybe that person is more important to our application, or that object is more important to our application. Okay, so what happens in non-maximum suppression, it is, along with this bounding boxes, our cascaded networks are also going to give confidence values. That is how much our model is confident that it is a face, or it is some phone, or it is some cycle. Okay, as we are going to discuss only the face detection, so now whenever the model is have drawn a bounding box, our model is going to assign a confidence value to each and every bounding box. Okay, I'm 75% confident that this is face, I'm 80% confident that this is a face. Okay, so now I'm getting two overlapped boundary boxes where the confidence of one bounding box it is 50%, and the confidence of another bounding box it is supposed 20%. Okay, I assume like the bounding box with 50% it is very small, and the bounding box with 20% is very large. Usually what happens it is, the boundary box with 50% confidence it is removed based upon the size, but which is not suggested. So our non-maxima suppression considers the confidence values, so it is going to remove the boundary boxes with low confidence values, not based on size. It is going to remove the bounding boxes based on the confidence values that are generated by the model itself. So all these bounding boxes coordinates are again converted to unscaled image coordinates, and again you are reshaping them and passing it to the next cascaded network. So finally you are going to get the face classifications. You are going to classify whether it is a face or not, and also you are going to draw a bounding box around that face just to visualize it. And next you are going to localize the landmarks, which are nothing but the features. These landmarks localization, which is nothing but you are going to localize which part is eye, which is nose tip, which are the left corner of your lips, or which is your chin, what is the boundary of your face, and all these landmarks are localized. So these are the outputs of attentive net, like you're classifying whether it's a face or not. After classification you're drawing a bounding box along with confidence values, and next you are going to localize the landmarks. Okay, so these landmarks are used to check whether the face is aligned or not. Okay, so now here you can see you have given an image. Now we have detected the face by drawing a bounding box, and next you are going to check whether the face is aligned towards the camera or not. Okay, now to check whether the face is aligned towards the camera or not, so now you can see a simple flow diagram here, like you are going to take this landmarks which has given as an output from our attentive net based upon your MTCNN. Okay, so now so what we are checking, whether the face is aligned towards camera or not. Okay, so now to check that, first we need to consider some average positions of the face according to our camera located of our device. So now the facial landmarks whatever we have received from MTCN or attentive net, and will be converted into average positions. Just we are going to convert into a matrix form. Okay, so now we are going to calculate the similarity transform between the average positions of the face according to camera and the positions we have received from our attentive net. Okay, this the similarity matching is done by using your calculating the mean and covariance. Okay, so I think by using affine transformations, these mean covariance are used for computing affine matrix or affine transformations. So in this affine transformations, usually you can see the different types of movements, like it can be rotation, it can be shear, it can be scaling and all this, but as stick to our application, just you are going to consider only rotation matrix from affine matrix, no need of all the remaining. Okay, so now after calculating your mean and covariance between these two matrices, this covariance is used to compute your affine matrix, where from this affine matrix you can get the angle by which your face is turned towards in the terms of arctangents or radians. Okay, by which angle your face is turning, whether it is right 0 degrees or whether it is 45 degrees, whether it is 90 degrees and all that. Okay, so now we are going to calculate that rotation. Okay, so after calculating this rotation, so if your length of your aligned phase is 160, then it is like okay, the phase is aligned towards camera. So now I can start with working the remaining part of my algorithm, like to recognize the phase. If the length of your aligned phase is not 150 after applying your affine transformations, that is after calculating your rotation angles, it is like the phase is not aligned towards camera. If the phase is not aligned towards camera, we can't recognize. So there is no meaning in running your algorithm or running your model. Just you can give an alert like no phase is aligned towards camera, because without checking face alignment, if we keep on running the face recognition module, it is wasting of their computer resources. So that's the reason usually in the most of the research papers you see, like obviously they go with the face recognition as soon as they complete the face detection. Why I'm saying to include face alignment in between is to reduce the resource computing resources, to reduce amount of computing resources. Okay, so that's the main importance of the face alignment implementing face alignment before starting with the face recognition module. And next, coming to the final stage, that is a face recognition module. This is an example of the ProctorNet architecture along with the triplet loss function. So now here you can see like this module is your inception ResNet, which is a main part of the heart of the ProctorNet. Okay, here you are having combinations of stem inceptions. I show you the what is the architecture, or what are the layers included into, or what are the operations included under these different modules, like stem inception ResNet A, reduction A, inception ResNet B. As a whole, what happens here it is, for this inception ResNet V1, we are going to give three types of images as an input. Okay, the one is your anchor, one is your positive, and one is the negative. This happens during the training process. Okay, what these three is, suppose if I let's consider an image of some person X. Okay, the image of person X will be positive, because I'm going to train him like, if you're going to receive the images related to him, he is nothing but, he is none other than X. Okay, so the image of X is positive. Okay, so now I'm going to give the other images, the images other than X, I'm going to consider it as a negative. Okay, and now I'm going to give some image anchor relative to the X itself. Okay, three images: anchor, positive, and negative. Okay, now what? So these three images are given as an input to your inception ResNet V1. Okay, the first I'm going to give the image anchor to inception ResNet V1. It is going to adjust its weights. Okay, fine. Next I'm going to give again images, image positive image. Again it is going to generate some weight. Okay, and again I'm going to give one more input negative. Again it is going to get weight. Okay, now what happens actually in training of any model? When I'm training, the weights of your nodes or the weights of your neural network should be adjusted. Okay, so now how these weights are adjusted in our ProctorNet? These weights are adjusted based upon these three images: anchor, positive, and negative. Okay, so after giving these images to as input your inception ResNet, what happens it is, I'm going to receive an embedded vector as an output. This embedded vector is nothing but it is simply like a hash code. Okay, I think all of you are familiar with hash code. So whatever I give, what is the main familiarity of hash code, importance of hash code, it will be an uniqueness. Okay, so for every phase we are going to generate an unique embedded code, which you are calling it as an embedding here, embedded vector, which is nothing but a simple hash code. Okay, if you're suppose if I'm having 70 persons in my class, I'm going to have 70 unique hash codes. So no way two persons is going to have same hash code or same embedded vector. So for anchor image, I am getting one embedded vector. For positive image, I am going to get one embedding vector. And for negative image, I have received one embedding vector. So now I am going to compare all these embedding vectors. Okay. So now based on these embedding vector, the distance between these embedding vectors, I am going to adjust the weights of the inception resonance such that the distance between this anchor image and positive image should be low when you are comparing with the distance between anchor and negative. Okay, because the anchor should move towards positive, not towards negative. In such way, you are going to adjust the weights. It means that the positive image belongs to X, the negative image belongs to Y. This anchor is also the image, some image of X in some other angles. So now my model should be able to recognize, like in any pose or in any angle, he is X. So the distance between this anchor and positive should be less when you are comparing with the distance between anchor and negative. So your weights of your inception resonance should be adjusted in such a way. The same thing it is showcased here. So that's the reason you are calling it as a triplet loss. Triplet, you are giving three different images as an input, and based upon the embedding vectors of these three different images, you are going to adjust the weights. Okay, that's the reason you are calling it as a triplet selection or triplet class. So just the same thing is projected in the form of algorithm here. You are going to calculate the distance between the anchor and positive, the anchor and the negative. Okay, always between the anchor and the positive should be minimum, and the distance between the anchor and the negative should be maximum. The adjustment of weight should be done in such a way. Okay, so now your model is ready to recognize the phases in different illuminations, different angles. Everything is depending upon that how much you train your model. As this is a deep learning model, as we have discussed earlier, like the deep learning model works or performs well when it is trained with a huge amount of data. Okay. So now this is a description of the different modules I have seen here. So you can see stem, inception, ResNet A, reduction, inception, ResNet B, reduction B. So this is the structure, or this is the operations which are involved in your different layers like stem, inception, ResNet A, B, C, and so you are having different convolution operations and ReLU activation functions, and after where you are concatenating these filters, and also you have implemented 3x3 max pooling. I think your max pooling. So whenever you're having 3x3, it is nothing but a 3x3 array, a 3x3 matrix, in which you're going to consider the value, the maximum value there. For example, the values are like 1, 2, 3, 4, 5, 6, 7, 8, 9 in 3x3. So whenever you're performing max pool operation, you're going to consider the value as it is 9. And also you're having merging operation. So these are the minor details of the layers which are included in your inception ResNet. Okay, so these are simple outputs after implementing your face detection. Like, see, the database we are having here is 200 images, where we are having different models like Vardhan AI and attentive system, which is combination of attentive net and proctor net that we have discussed right now. So now here you can see in Vardhan AI, the main difference here it is the face alignment module is not included here. So as we have discussed, what is the importance of face alignment module into face recognition system. So as the face alignment module has been embedded into your attentive system, now here you can see like the true positive count has been increased when you're comparing with the Vardhan AI. That is, among 200 faces, it is going to recognize the 190 positive faces correctly. Even the false positives have been reduced with the attentive system, and also false negatives is also reduced. And finally, coming to the final detection accuracy rate, the accuracy rate has been increased from 93 to 95 in attentive system. Okay, so this is about only detection. Now here you can see here in the below pictures, it is not recognizing, it is detecting here. So coming to the A, the first it is used in Vardhan A, and where the second image it is using attentive systems. In Vardhan AI, you can see like it has been detected the images in the back poster also, which doesn't happen with the attentive system. That's the main the main charm of multitask cascaded networks, which doesn't happen in your Vardhan AI. Vardhan AI is not using multitask cascaded neural networks. So this is the 128 dimensional vector as we have discussed here. Whenever you are giving an image as an input, your inceptionist net, you are going to generate an embedded vector. So you are going to generate an 128 dimensional embedded vector which looks like this. Okay. So whenever you are giving training your face, so it prompts you like turn towards left, turn towards right, and see towards the camera. It is going to generate the 128 dimensional vectors in the three directions: left, right, and center. Okay, so this is the dimensional vectors of a single person. Okay, so now whenever it is going to match the features of the input image with the features of the images stored in your database, so it is going to match this vector. So this acts as a unique hash code. Sorry. So now here you can see even the face recognition. It detects who it is, and our model, that is attentive net and prompter net, is able to recognize even when when the accessories have been embedded into face. You can see now here, you can see the confidence values here. It is completely okay. It is 100% confident. Even here you can see the nose tip is visible here. So even here it has been recognized with 100%. But coming to in the third case in the C, you can see just you have detected the face only with a confidence value 62, not 100%. Okay, because even the nose tip is covered. So just you're only confident with 62%. Okay, but whenever you're covering the half of the face, only eyes are visible. So here even it is not able to detect that it's a face. So now you can see what is the accuracy and error rate of attentive net and proctor nets with the different data sets. Always when you say like our model performs in this way, in that way, you have to compare the model on different types of data sets. Okay, not only comparing with the existing model, also you need to compare with the different data sets. Like here you can see you have compared with YouTube face data set, labeled faces in the wild data set, proctor data set, so which are very famous for face detection and recognition modules, which you can get it from Kaggle. And this proctor data set, if you need this, just you can give me a mail. It is a customized data set by me, so I can provide you. So these are the different accuracies. And so this is about the face recognition using deep learning, where by using attentive net and proctor net. So if you have any queries at any time, you can mail me, you can drop a mail to me. So I'm ready to clarify your doubts. And now the session is open to you. So if you are having any queries, just please post in the chat box.
Dear participants, as mentioned in the brochure that we have today 2 sessions. The first session is over. So if you have any queries, you are asked to interact with Tejasvi ma'am.
Sir, also give my mail ID in the chat box, so you can mail
Yeah,
me
yeah.
at any time.
You can share your mail ID and contact number. Otherwise, I would like to propose vote of thanks to Dr. Tejasvi, and thank you for accepting our invitation to deliver this session. It was good, informative, and you have dealt on applications of machine learning, deep learning, which is deep learning and machine learning, which is the subset of artificial intelligence. You have also explained about face detection and face recognition. What are the steps to be followed while executing this algorithm?
So thank you, ma'am, for sharing your knowledge with us.
Thank you. Thank you so much for giving me this opportunity.
Yeah, thank you, ma'am.
Thank you.
Now, dear participants, we have another resource person who will be deliver a talk on demonstration of a Tableau tool for data visualization. I warmly delighted to take the opportunity to introduce our distinguished speaker of this pleasant evening, Dr. Ravi Kant Motupalli, Assistant Professor of VNR Vignan Jyoti Institute of Engineering and Technology, Telangana. Dr. M. Ravikant obtained his PhD degree from Acharya Nagarjuna University, Guntur, in the field of data analytics. His broad interests and research areas are data analytics. He had 15 years of teaching experience. He was awarded with a postdoctoral fellowship from Srinivasa University, Mandalore. And also, he was very zealous and thirsty for knowledge, so that he was pursuing MBA in data sciences at Symbiosis University, Pune. Has a good academic career. As an ardent researcher and a fervent academician, has published more than 25 research papers in national level and edited 7 chapters in books, 5 edited textbooks, has completed 7 patents, and as an enthusiastic member, he was attended in 12 conferences. Currently, he was working in assistant professor in VNR Vignan Jyoti University of Technology, Telangana. Now, I cordially invite Dr. M. Ravikant sir to deliver your lecture on demonstration of a Tableau tool for data visualization.
Yeah, thank you, ma'am. Thanks for the introduction.
Thank you, sir.
Yeah, good afternoon, all.
Good afternoon, sir.
Yeah. Thank you, ma'am. So, participants, so before starting our session, so you can find one link in the chat box or even in your WhatsApp group. Also, I have posted one link. So it takes only just some couple of minutes. So if you click on that, the Tableau desktop version, you can download it. So I'll be waiting for a couple of minutes. So once download is done, let's start our session. So please don't waste much time. We have only 1 more hour. So first initial 10 to 20 minutes. So depending on your queries, let's have some theoretical session. So after that, we will be starting our practical session. So it will be very simple. You don't require any programming language skills or something else to be expertise or any algorithm. So it will be very simple. Even school students also will be able to use this Tableau tool. So please, if you are able to concentrate for the next half an hour or so it will be interesting for you also. So please, all of you, download that Tableau desktop version and open that and be ready. So let's start after a couple of minutes. Okay, so even if you are unable to complete the download, so just you download the file and click on that. So by the time we start our practical session, so you will be completing that installation and all. Okay. So let's get into the session. So myself, I'm Dr. Ravikant. I'm working as assistant professor at Hyderabad. So VNR VJIT in the Department of Computer Science and Engineering. So today I'm here to give you a session on one of the visualization tools which is mostly used nowadays. So the name of the tool, we call it as the Tableau, Tableau. So just before going very deep into this usage of Tableau tool, so just I have posted one more link in the chat box. So you just click on that. I just want to know how many of you know about this tool. So depending on your awareness on the tool, so I can decide whether I should go very deep into this or I should cover only basics related to this. So just you can give your opinion there just by clicking either yes or no. It's just like poll type. So I have posted in the chat box. Just if you are previously, if you have heard about this tool, just click on yes, or else you can click on no, or if you don't have any idea at all, so you can click on that no idea at all also. Just to give you your opinion enough. Yeah, instead of posting in the messages, so there you can click on that link. So then I will be reaching some conclusion. So out of the 40 participants, how many of you are aware about this? Good. Already some 4 participants have given your opinion. So say, 3 of you have said yes. 1 of you said no idea at all. Fine, no problem. Others, please respond. It will be interesting if you are giving your opinion, so that it will be a choice for me to cover only basics or to go very deep into this. Okay, you can keep sending your opinion. Okay, so let's start our Tableau. So what is Tableau? Who developed this, and for what purpose we will be using this Tableau? So this Tableau software was developed by one of the organizations which we call it as the Salesforce. So it is also one of the important trending tools which we are using nowadays, Salesforce. So this Tableau was introduced by this Salesforce organization. So even though Tableau is a single tool which we will be using it for visualization, internally in the Tableau we will be having 5 different types of products. So depending on the context, depending on the necessity, whichever the type of version we feel convenient for us, so you can choose that version and you can use it for your purpose. Okay, so coming to those 5 versions, the most important version, so which we are going to demonstrate after this, we call it as the Tableau desktop. So most important version. So this Tableau desktop is the tool where we will be having this drag and drop authorized features. So simply whatever the data you want to feel, you want to see, you want to view as part of this visualization, so you will be dragging and dropping those into our Tableau tool. So it's very simple one. You can use it in a very user friendly way. And internally in this Tableau desktop version, you will be having 2 premium versions. So depending on if it is only for you, your own purpose, if you are using it, you will be having Tableau desktop individual, or if you are using within the organizations, so then you can go for Tableau desktop professionals. Only the features will be varying. So if it is for individual, you can have your own customized tool. Suppose if it is for professionals, so there are some extra premium features will be having. Say for example, you can have some live data contributions. Suppose if the organization wants to publish any data so that it should be access to all the people in the organization. So in such case, you can go for Tableau desktop professionals. So coming to advantages of this Tableau desktop. So as I said, most important thing is drag and drop functionality. Simply, you don't require any expertise. Even if you are unable to write any queries also, still we can see the data which you want to see as part of the dashboard. Okay. data connectivity is very simple. It will be kind of supporting wide range of data, whether it is structured, unstructured, or semi-structured, whatever the type of data it is. Our Tableau desktop will be supporting that. And the most important advantage of this Tableau desktop is real-time data analysis will be available in this Tableau desktop. So it's very important nowadays. So what is the most important requirement related to this data analysis? We should be able to do it on real time. So if you are able to do it on real time, so most people will be preferring to use this tool. Next, there are only one or two demerits related to this Tableau desktop. One is it is very costly, but still, if you want to use it, if you want to practice, or if you want to demonstrate to your students, if you want to use it for research and all, some free versions will be available. So for 3 weeks, depending on the type of version you download. So you can have that 21 days free trial. You can download, use it for 21 days. Once it is done, no problem. Once again, you can download it once again using the same mail ID also. But it will be available for only 21 days. If you feel that again you want to use the same tool, you can download it once again and you can use it. So this is about the first product in Tableau, which we call it as the Tableau desktop. So next, second type of version, we call it as the Tableau server. So this Tableau server, it is a little bit most costlier compared to the Tableau desktop. Suppose if people want to work at same database at two different places. So in such cases, we can go for this Tableau server. So you'll be having some controlled and consistent access to data. Why? Because the database will be connected to the server. So wherever you have, if you are authorized person to access the data, so you can publish, you can distribute, and you can manage your representations. And even the scalability is also one of the important feature of this Tableau server. But coming to demerits, having this Tableau server, it's not that easy. You need to maintain these servers and all. So infrastructure wise, if we consider, it will be a little bit more costlier compared to Tableau desktop.
Hello.
Hello.
Where are you?
So next, coming to this third type of product, we call it as the Tableau Online. So Tableau Online, it's almost same as Tableau server, but the only difference is it's some cloud-based platform. So if you wanna avoid this overhead of maintaining the server and all, so in such cases you can go for Tableau Online, the third type of product. Fourth one, we call it as the Tableau Public. Actually, it's a free product of Tableau, which provides some limited functionalities. All the whole functionalities which we have in Tableau desktop, Tableau Online, or Tableau server will not be in Tableau Public. Since it is some free product, only some limited functionalities, basic functionalities which we require for performing analysis and all. Only such things we require here. Next, the last version, we call it as the Tableau Prep. PREP, it stands for data preparation. Actually, it is some ETL tool, extract, transform, and load tool. It's created by Tableau. So it is a special version, so where we can have this data cleaning, data shaping, combining data from diverse sources, so that it is ready for analysis and visualization in Tableau. So these are the five different versions of Tableau. So depending on context, if it is for your own purpose, if you are using it individually, you can go for Tableau desktop. Suppose if different people from different locations wants to connect to the same database and access, you can go for either Tableau server. If you feel it is difficult maintaining a server, you can go for Tableau Online, which is a cloud-based platform. If you want only limited functionalities, in such cases, you can go for Tableau Public. And the last one, Tab Prep. It is an ETL tool. So where if you want to give more importance to this cleaning of data, shaping of data, in such cases, you can go for Tableau Prep. So these are the 5 different products we have in Tableau. So finally, what is Tableau means? It offers some powerful visualization capabilities that provide very deeper insights and facilitate better decision making across multiple data sources. Okay, so this is some brief introduction about Tableau. Now I'm going to show you the usage of this Tableau desktop. So if you are already you have downloaded that, you can use it. Okay, just all of you please open the file. So if you have installed it, it's fine. Even if you are unable to install it, or else simply you can follow my screen also. Okay, just I want to know how many of you have installed this, so I have posted one more question for you there. So whether you have completed this installation of Tableau or not, so you can respond there. So if you are in front of your system, please download it and follow. It will be very simple. So I guess my entire screen is visible to you, right? May I know whether my screen is visible to you? Are you able to see the desktop tool? Please, anyone of you respond?
Yes, sir.
Yeah, okay. Thank you, ma'am. Thank you. Okay. So this is how initially how it looks. So whenever after completion of the installation of the tool, once you open the tool, so whatever you are seeing on the screen, so this is how it will be visible. Okay. So the beauty with Tableau is you can connect to any type of file. So whether it is Microsoft Excel or text file, JSON file, PDF, spatial data, statistical file, still there are some more options. Since it is some downloaded free trial version, so it is not showing you the different file formats supported by Tableau. So here you can see here on the left hand side, what are the types of files it is supporting. So Microsoft Excel, text file, JSON, Microsoft Access, these are the different types of file formats supported by our Tableau. So in our session, what I am going to do is, actually I have shared two data sets with you. One, it is some Dhoni statistics, another one Superstore. So depending on whichever the data set that is familiar for you, which are if you're interested, so that you can use it. Okay. So now what you do is, all of you download the two data sets. Okay, so first step we need to do as part of this Tableau is you need to connect to a data set. So what I am doing right now, the data set which I have shared to you, it is an Excel file. So simply click on this Microsoft Excel. Okay, so wherever you have, whether you have installed it on your desktop or somewhere internally. So just to demonstrate to you the tool, I am selecting this Dhoni detail statistics. So after selecting the data set, you click on open, so automatically the data set will be opened. Just wait for a few seconds, the query should be executed. So it will be ready once the data set is imported into our Tableau tool. Okay, so this is the first step. The first step what we need to do is we need to connect to the data set on which we want to perform our visualization. Okay, so there left hand side some options will be there. So there if you click on to which type of file you want to connect, so that you can have it. Okay, so before starting visualization, it would be better for us if we have some analysis on the data set, what are the fields we are having internally. So for that, if you have some basic information, so what are the different data types, what are the possibilities where you might be having some null values, some at some occasions the data might be missing. So if you have some small glance on this data set, so it will be easy for us while performing data analysis, data visualization, right? So this is the data set. In any data set which we import into our Tableau tool, so it will be majorly categorized into 6 types, 6 data types. Just like in how in our programming languages we will be having, suppose if you take some C language or Java and all, how we will be having int, char, float and all. Similarly, in our Tableau also we will be having 6 different types of 6 different data types. First one, which we are already familiar, string values. So simply, if you have any text, so normally we will be putting it in either a single quote or double quote. So if you are representing as some series of characters, so that we call it as string values, data type number 1. Number 2, we call date. One will be representing only date. So that is the second data type. Third one, in some occasions, along with the date, you will be having time also. So you can represent both date and time in the same data value. So that is the third category. Fourth one, which we will be mostly using, almost every data set will be having, we call it as the numerical values. Fifth, depending on the context only we will be having, we call it as Boolean values. Boolean in a sense, only two outcomes will be there, either true or false. And last one, it is geographical values. So where we can represent the latitude and longitude of the location. So apart from these six, suppose there might be very rare cases where this data doesn't belong to any of the six categories which I have mentioned just now. So in such cases, one more new data type is there. We call it as the mixed value or cluster value. Okay, there might be some occasions, or you might be using some image. If you are unable to decide which type of data type it is, so then by default it will be treated as some mixed value or cluster value. Here all of you. So six data types. First one, series of characters is string. If you are representing only date, it is date value. If you in the timestamp, even time is also there, it is date and time value. Fourth category, which we will be mostly using, we call it as the numerical. Fifth, occasional Boolean values, means either yes or no, true or false, or 0 or 1 we will be representing. And last one, geographical values. Suppose if you are using any location, so further this latitude and all latitude and longitude will be existing. So even that also we will be showing as part of our visualization. Okay. Now, before starting the visualization, so let me show you what are all the fields we are having in our data set. Okay, so you can see here. So since it is what is the name of the data set we have taken? Dhoni detail statistics. I guess you are all familiar with MS Dhoni, our captain previously. So related to his, some data is available in the internet. Just I have downloaded it. First one, serial number. So normally serial number we will be having only numerical values. So the symbol we will be using for this numerical values is hash symbol. So you can see it here. So wherever you have this hash value, say for example number of runs scored by him, number of catches taken by him, number of stampings taken by him. So at all these places you will be having this hash symbol just to identify what type of data it is. So wherever you find hash symbol here, so means where you are having numerical values. Next, date. Actually calendar symbol should be here, but the reason why it is showing it as ABC some string means in the throughout the data set, if you are not following same format for the representation of the date, instead of treating it as a date, it will be treated as a string. So for that reason here it is showing ABC, capital A, small bc. So wherever you encounter this ABC symbol means it is a string. Next, if you see the next column, country played against what are the opponent countries he has played. So here you can see some globe symbol. So wherever you find this globe symbol means the data type is geographical value. So means suppose if you click on this Bangladesh, and if you want to represent Bangladesh in our visualization, so there the latitude and longitude of that country will be displayed. Next, stadium. So here also it is showing as a this string ABC, since it is the name of the stadium. Or else if you want this for stadium also, if this geographical location is available, then you can have this globe symbol will be used here, means it will be showing latitude and longitude. Next, as I said just now, runs numerical values, it is showing hash symbol. Catches, it is a numerical value, so here also it is a hash symbol. And you have one more value here, stampings, so that is also numerical value. So that's why here you have hash symbols. Okay, so 6 different symbols. If you are finding ABC, it is a string. If you are finding only calendar symbol, even in your phone also, whenever you want to access the date, calendar symbol will be there. Only calendar symbol means it is date. Suppose calendar symbol, in that calendar symbol, in the corner we will be having clock symbol, means it is showing both date and time values. Numerical values, always you will find hash. Boolean values, actually in this data set we don't have any Boolean value, but normally whenever you encounter these Boolean values, so the symbol will be T-F. So T stands for true and F stands for false. Okay, some rare cases and some versions it will be like yes or no also, Y/N. Or in some versions it will be 0/1, means 0 indicates a false condition and 1 indicates the true condition. Next, for this geographical values, you will be having the globe symbol. And as I said, one more special data type is there, mixed value. where you are unable to decide which type of data type it is, some different symbol will be there. We can't even describe that symbol also. It's a rare symbol. So if you are missing the above 6 symbols, whichever I have mentioned just now, so it can be treated as the mixed value, means it is mix up of either one or more data types. Clear? So now let's start our visualization thing. So the first thing what we need to do is we can create a worksheet. The first step or the first thing we are going to create is worksheet. So here at the bottom of the screen, something you can find it as sheet 2, means already I have created one sheet 1, so that I have deleted. So for that reason it is showing sheet 2 here. So but whenever if you are doing it for the first time, here at the bottom of the screen after data source in the sense whatever the data we have extracted just now, so that is the only detailed statistics. So all of you please click on this sheet 2. So once you click on this sheet 2, here you will be seeing the original Tableau tool. Okay. Now first let us concentrate on this left side on the screen. So what we are seeing here. Okay. So all the attributes whichever we have in our data set, by default we are not going to do any exercise on the data set. So it will be categorized into 2 partitions. You can see here, you can find one thin line here. So 2 partitions. So the first partition we call them as the dimensions, and the second partition we call them as the measures. Okay. So all the fields, all the attributes, all the parameters whichever we have in our data set, it will be categorized into 2 partitions. One partition is dimension and the other partition we call them as the measures. So what's the difference means, normally dimension it contains some qualitative values, say some names or some date, like these features, so which you can use for categorizing or segmenting or revealing some data in the data set. So all those comes under the dimensions. Next one, measure, second partition, means it will be containing numerical values that can be measured. So for example, say here you can find some catches can be measured, runs can be measured, stumpings can be measured. So like this, some things which can be measured, so we can call them as the measures. Here 2 things, one is dimension and the second one we call it as the measure. Okay. So now what we can do is, first let us create one worksheet to show against each country how many runs he has scored. Okay, so for that purpose what I will do is, from dimensions I am selecting one of the attribute country played against. You can see here. So the first one, country played against. So what you do is, you just click on this country played against, drag it and drop it at the columns. Okay, so you know everyone, table means you will be having 2 things, rows and columns. So what I have done is, I have dragged this country played against and I have dropped it at the columns location. Now see here in the screen automatically. So all the countries against whatever the countries he has placed, all the names of the countries have been displayed here. So if it is not visible here, so what I will do is, instead of taking this countries played against in the columns, I will drag it and drop it at the columns. See how it is going to change. Then, okay, so these are the list of the countries where against opponent teams where he has played. Clear? All of you, just respond once. Are you able to see this visualization tool? It is getting reflected. Anyone? Are you able to see this tool or not?
Yes, sir.
Oh,
Yeah, able to see. Sir, able to see.
Thank you. Okay, so now any type of data you can take it on either rows or columns. Okay, you will be having this both x-axis and y-axis. So depending on the context, if you feel that this particular attribute it will be give more importance if you put it as rows, you can use it as rows. It's left to your importance. It's not like any formula or programming language which we need to follow the exact syntax. So whichever you feel convenient for you, you can have it either at the rows place or you can have it at the columns place also. So here in the right hand side, you will be seeing some different types of maps. Okay. So wherever the maps it is getting highlighted. So if you are seeing here, only one map is getting highlighted here, some geospatial map. Why? Because right now in the data set, I have selected only countries. So to represent these countries, some suitable, just like recommendations, which type of graph is suitable for us, only that type of graphs will be highlighted here. So if you feel that is convenient for your visualization, so if you click on that, automatically it will be changed to that. Okay. So right now here you can see, so far we are using only one dimension, that is also geographical value since it is countries. Okay. So next what I want to see here is against each country, how many runs he has scored. I want to show it as a worksheet. Okay. Now Africa, Afghanistan, Australia, you will be having different countries here. Okay. So now my task here is against each country, I need to show how many runs he has scored. So what I will do is I will select this runs value from the data set, drag it and drop it at the columns. See here how beautiful it is. So by default, it is showing all the countries, and against each and every country, what are the number of runs scored by him against each and every country. Even if you are keep your mouse on that particular chart there. So here, country played against. What is the name of the country? Africa 11. What are the number of runs scored against that? 174. Or you choose one more against England. The number of runs scored by him is some 1546. Simple, right? So it's not only one attribute, one versus another attribute. If you feel that since he is not a just a batsman, he is keeper also. Suppose if your intention is you want to check the number of catches taken by him against every country, then you can drag and drop one more attribute also there. Say for example, catches. So what I'm doing here is I'm dropping this catches here. Now see how our chart is going to respond. Clear? So actually if you see here against every country, it is showing catches. Suppose if you want to compare this runs and catches, instead of having this catches value at rows, you simply move it to columns. Now it will be showing very clearly. Then, so the first part, it is showing against each country how many runs he has scored. In the second part, it is showing how many catches he have taken. Suppose if you feel that this particular view which you are seeing right now, it is not convenient for you to have some analysis, it's left to us. What I will do, I will change this runs and catches into rows, and I will change this countries played against into columns. Now see here, I feel compared to the previous display, here it is more convenient for us. So you can have runs and you can have catches also. Okay, so as I said, since he is a keeper, apart from this catches, you will be having one more attribute called as stampings also. If you want to have all the three in a single chart, you want to check how many runs he have made against each country, how many catches he has taken against each country, and how many stampings he have made against each country. You can have third attribute also here. So it's left to you. Now see here, I'm adding one more attribute here, stampings also. Now you can find the three things. Okay. Topmost, it is showing runs. Middle, you can find catches. And at the bottom, you can find stampings. Suppose if one more field is there, say for example, some run out or something else, that data is available. Even that also you can drag and drop here. Okay. Now the thing is, whatever the data value you are dragging and you are placing it either columns field and rows field, definitely it will be reflected here. There is no doubt in that. But the thing we need to consider is it really worthwhile placing all the values in single worksheet? Okay, it will not be possible. Say for example, in your class some 60 students are there. You want to have analysis on all the 60 students. If you are placing the data of all the 60 students in one single worksheet, definitely it looks some clumsy. You will not be having any clear clarity on that, which students are performing well, which students are not performing well. So in such cases, what we can do is, in Tableau, the second step, we call it as the dashboard. What do you mean by dashboard? Means if we are unable to represent the entire data analysis in single worksheet, we can make two worksheets, sorry, and if you combine the two worksheets, that can be created as a dashboard. Sometimes what happens, if you are say, take this cricket example, you are not doing it for one single cricketer. If you are doing it for 11 different cricketers, what you can do is, you can have some detailed graphs, detailed worksheets for each and every cricketer. Say for example, runs related to batsmen, wickets related to bowlers, stumpings and catches related to wicket keeper, some captain win or loss ratio. Like this, we can create different worksheets. But different worksheets we can convert into dashboard. For batsmen, we can have one dashboard. For bowlers, we can have one dashboard. Exclusively for wicket keeper, you can have one dashboard. For captain, we can have one dashboard. Now we have 4 dashboards. Now all 4 dashboards, it will be difficult for us analyzing in one single chart. What you can do? Now you can combine dashboards into one more board, which we call it as the storyboard. Okay, now let me explain you the sequence once again. The first step, we call it as the worksheet. If you are having more than one worksheet, you can combine into dashboard. If you are having more than one dashboard, you can convert it into storyboard. It's not that compulsory everywhere you should have this worksheet, or worksheet is mandatory. Everywhere it's not compulsory that you will be having this storyboard or dashboard, depending on the requirement. If you want to display more charts, if you want to go for more analysis, in such cases only you can create these dashboards and storyboards, or else we can stop with worksheets also. Okay, now it's clear for you how to create a worksheet. Clear? Now on this worksheet which you have created, we have numerous options available. You can change the color, you can change the font, or else for some values whichever you feel important, you can highlight those particular values. If you feel any values are not that important, you can remove those values from your chart. All these sort of things, now you can start doing your analysis here. Or else if you are good at SQL, if you don't want to change it sequentially, if you want to change it by writing some queries also, we will be having some options to write queries. If you write that query, based on that query, it will be reflected on data set. Only that query outcome will be displayed on our screen. Okay. So what we will do is, first let us start with this marks here. You will be finding some here. First one, we call it as the color. So it's very important. Why? Because for representing all the bars with one simple color, it may not be so attractive. Suppose for runs, you want to use one color, for catches, one more color, and for stampings, one more color. So what we can do is, you can go for this color option. Runs, since it is already in blue, let's leave it. Let us change the color of the catches. So you click here on catches, go to this color option. So let me select this orange color or something else. See there. So automatically for the second attribute, it has changed it to orange. Stampings, say you want to use one more different color. So you can take some other color. So automatically it will be reflected here. So now see here, it looks more attractive compared to the previous worksheet which you have created. Okay. Now 3 things. So one for runs, another color for catches, and another one for stampings. Okay, normally when you want to prepare your data sets for research paper and all, doing some analysis, creating graphs and all, if you feel that in the research paper, if it is not fitting there, we will be reducing our size. But if you are reducing the graph size there, so it doesn't look attractive. Manually doing also, it's time consuming. So in such cases, what we can do is, we have an option called here size, where we can reduce the size of the graph also. So if you click on this size, so something like it will be displayed here, just like how we will be reducing our Word document size and all. So if you want to increase it to the core, you can take it to the next level. So you can see the graph there. Right now it is getting reflected only for stampings. If you want to reduce, you reduce, or if you want to have only minimal size, starting size. Now see here, just it is showing one single line there. So same thing, even if you go for catches, there also you can implement this size option. See there, automatically, or the orange bars and all got reduced. So same thing, you can do it for even runs also. Either if you want, you can increase their size, or if you feel that much it's not important, you can reduce the size also. Next, the third option, we call it as the label. Now here, by seeing the graph, you don't know what is the value here unless you place your mouse cursor on this. If you place the cursor, then only it is showing Australia, number of catches he have taken 44, number of runs he has scored are 1660, and number of stampings he has taken 18. For the remaining, see here, it's not showing any values unless you keep your mouse on the bar, then only it is showing the values. But if you feel by default, even the values also should be displayed on the top of this bar, you can go for this, click on this label. Okay, show mark labels. So you'll be having a option here. show mark labels. So if you apply that, now see here, even without placing our cursor here, all the values it is showing here. Okay, so even if you don't place your cursor also, you can see here 174, 36, 1660. Same thing you can do for catches also. Just go to these catches, go for label, you can click this option, show mark labels. See here, everywhere the values are getting reflected. Same thing, you can go for these stumpings, go for label. So if you click on this show mark labels, so everywhere it is showing. Even if you want to increase this size of the bar, just let it be some medium size, so automatically even the size of the bar also will be reflecting. Even okay, runs it is already good, fine. Now see here, everywhere on top of the bar you are able to find the labels also. Next, coming to this detail, actually for this data set it will not work out. Generally what happens in this detail is, if you click on this detail, the information related to the particular attribute will be displayed. Okay, fifth option we have here called as the tooltip. So what is this tooltip means? Sometimes, as I said just now, if you want to write your own exclusive query, what type of data should be displayed on the screen, so you can go for this tooltip, then automatically it will take you to an editor. So in this editor you can write your own queries. So if you don't want to display the names of the countries which are right now which are not playing cricket, say for example if you take this Zimbabwe, Hong Kong, Ireland, some Africa 11, so these type of teams will not be playing cricket right now. So if you wanna delete those countries, you can write query here. So there you can eliminate all. So if you execute that query, automatically it will be eliminated. So if you feel that you don't have sufficient knowledge writing this SQL queries and all, we have an option called as filters here. So what you can do in this filters is, you can eliminate the countries which you don't want to see in this worksheet. So what I will do is, I will take this country played against into these filters. Okay, I am dragging and dropping it here. Now what I will do is, I will remove the countries which I am not interested. I don't want to show Africa 11. Next, I don't want this Bermuda. I'm not interested with this Hong Kong. Ireland, I'm not interested. Netherlands, I'm not interested. Let me delete UAE, United Arab Emirates. Okay, so all this I have, some countries I have eliminated. Now see how our graph is going to reflect here. So just if you click on apply, so automatically the filter will be applied here. Now see here, only limited countries. Okay, even some against Scotland also, he didn't score any runs, only 2 catches and not even stumpings also. So if you feel that if you want to eliminate that Scotland also, so what you can do is, you can go to that filter once again, edit filter. So let me remove that Scotland country also. If you click on apply, now see here, even that country also has been eliminated. So what are the values that you feel convenient? So in Excel means what you will be doing, if you feel that particular attribute is not interesting, you will be hiding that. Okay, so just like that, how we hide the data values in Excel. So here what you can do is, you can go to this filters. In this filters you can apply. So what are the things you feel convenient, which you want to be as part of your visualization chart, only those values can be displayed here. So we have one more thing called as pages. These pages and filters are almost the same, but how this pages option is different from these filters means, normally just like how in our textbook we will be having different pages in a sequential way, you can create different worksheets and there you can assign the numbers. So first this should be displayed sheet 1, next this should be displayed sheet 2, like the sorry, so like that you can have one sequential story. So again here in the topmost part you can find some options here. So one of the option you can have here is, you can swap these rows and columns. So previously what we have done, to have columns, in columns to have these runs, catches and stumpings, and country played against in the rows, I have manually exchanged. Instead of doing it manually, if you simply click on this option here, now see here, automatically rows and columns will be exchanged. See here, and if you click once again, it will come to the previous position. And you will be having some sorting option also. You can do it either in ascending way, or you can do it in even descending way also. So now here initially 36, some against highest value 1660, 569 coming down 1546. Suppose if you want to sort all these values, you have this option something called as sort. So if you click on this, now see here, from least value to highest value, automatically the values are getting sorted. Least 36, highest 2383, some least here from 0 to 71, and here from 3 to 25. Here stamping I guess it's not applied. So let me do it once again. Yeah, it is applied now. Something maybe some null values here there. So for that reason it will be deemed. Now suppose if you want in descending order also, that also you can do. So you can start from highest values and you can go to the least values. Okay. Now as I said, so far we have created only what? One worksheet. Suppose if you want more than one worksheet, suppose if you want only runs, you don't want to see catches here. So what you can do is you can remove these catches, and if you don't want to see the stampings here, what you can do is you can remove the stampings. Now what we can do is we have created one worksheet. You can rename this. So in this worksheet, what we are representing? We are representing only the runs. So you can go to rename and give the name of the worksheet as runs. I am renaming it as runs. So this is, let it be worksheet number 1. Now in the second worksheet, so if you click on this plus symbol here, a new worksheet will be created. So what I will do is I will represent only stampings here. Okay, so I will rename this as stampings. So let it be our worksheet number 2. Next, I will create one more worksheet number 3. So what I will do here is, here I will represent only stampings. So in this, sorry, our stampings already I have taken. Let me take catches. Let me remove these stampings and let me take catches. So let me rename this worksheet as catches. Okay, so you can see here 3 worksheets. First is runs, second one is stampings, and another one is catches. Now what we will do is let's combine these 3 worksheets into one dashboard. So dashboard symbol, it will be like this. So if you click on this symbol, new dashboard. So initially it will be empty. Why? Because in this dashboard so far we didn't include any worksheets. Now out of the 3 worksheets which you have created, suppose if you want to have runs, so drag and drop runs here. If you want to have stampings also, drag and drop the stampings also. If you want to have catches, drag and drop the catches also. Now see here. So if you scroll down, all the 3 things you can find here. So you can represent, we are representing stampings, we are representing catches, and we are representing the runs also. Suppose if you feel all the 3 things are not suitable to represent in one single dashboard, you can either move it upside down, you can reduce the size of one, you can increase the size of another thing, just like how we will be working on images in our Word document. So like this you can keep on increasing or decreasing the size of this. Suppose if you feel it is not convenient to represent 3 here, you can eliminate 1. 2 you can represent it in one dashboard, and third one you can represent it in another dashboard. So now if you create 2 dashboards, say for example, let me take one more dashboard. Actually I have created only one here. If you create one more dashboard, now you can combine these 2 dashboards into one last dashboard. We call it as the storyboard. Now in this storyboard, what are the dashboard which you have created, you can paste it here. Okay, for this you can add a caption here. So saying whether Dhoni should be as part of the team or not. If he wants to be the part of the team, you can explain here. You can say that he has scored very good against all these countries. If you don't want to be as part of the team, you can say that against some countries he has not performed well. Now, in this way, we can reach some conclusion. Okay. So it's a 5:20. We have another 10 minutes. So I will leave it for your queries and all. So just let me give some conclusion about this Tableau tool. So it's very simple if you keep using it very regularly. Okay, so whenever the most important purpose where we find is, if you want to do some analysis on your students semester wise how they are performing, or for your research paper if you have some results, if you want to compare some algorithms and all. So in such cases normally you instead of generating the graphs using Excel or some other tools, so Tableau will be having its own advantages compared to the remaining tools. In such cases, you can go for this Tableau. It's a very simple creating these worksheets and all, creating a dashboard or creating a storyboard. You can have you can use your own creativity. So it's not that it should be done only in this way. Only this color should be used, or only this type of graphs can be generated. Even different types of graphs also. Even I have used only here bar charts and all. If you feel bar charts are not convenient for you, you can click on these lines. You can go for line option, or if you want to use squares automatically, or even circles. See there how it is changing for each and everything. If you want to have only text, some ABC will be displayed. Some pie charts, if you want, you can use. All different types of options will be available. It's left to us how what sort of options we will be using. So automatic means by default, so this bar charts will be there. So this is how we can use this Tableau tool. Okay, so that's all from my side. If you have any doubts related to this, you can start asking.
Yes, thank you, sir. Yes, I request all the participants be involved in the questionnaire session and give your observations and inputs on the presentation of the topic.
Yeah, participants, if you have any doubts related to this, you can ask.
Sir, after that graph, how do you get to Word document? Save as or any other options?
This you can save it as a image, or you can save it as a PDF, or you can save it as a Word document also. It's left to us. You can the best option would be if you save it as a image, you can include it in your Word document. Simply you can copy paste the same graph into your Word document.
Okay, thank you, sir.
Okay, ma'am.
Thank you, sir, that you have explored and insights and how to use of Tableau's features to explore trends, outliers, and patterns in your data dynamically. Really, Tableau offers a wide range of features. This tool further will reveal more advanced functionalities for depth data analysis and storytelling. Thank you very much, sir. Yes.
Thank you, ma'am. Thank you.
Yes. I hope there is no further questions. Then we will proceed to the vote of thanks of the day, expressing gratitude for the fruitful day. First and foremost, I would like to express our sincere gratitude to our distinguished eminent speaker, Dr. Tejaswi Ma'am, has enriched the discussions, making this forum a valuable exchange of ideas. And my sincere thanks to Dr. M. Ravikant sir for enlightening us through his demonstration of the subject of demonstration of a Tableau tool for data visualization. Thank you, sir.
Thank you, ma'am.
Dear participants, I would like to wind up this webinar with a few announcements to the participants. Feedback form will be shared in the chat box, and all those who are attending the webinar and filling up the feedback every day will be receiving the e-certificate. So once again, I thank you all for making this webinar very effective and successful. Thank you one and all. I hope to meet you all for the 5th day of the webinar. Looking forward to tomorrow's program. Thank you, sir.
Thank you, ma'am. Thank you for the opportunity given to me.
Thank you, sir.